So I always talk about nature. Well, there was at one time I made a video about train vibrators and ancient structures and funny stuff. Point is, my educational videos are usually pretty down to earth. But tonight we're going to the moon! Well, it's pretty far. You could fit the Earth 30 times in the distance, or all the other planets in our solar system. Anyway, so Luna is pretty big. Bigger than Pluto, so like a small planet. At 1/4 of Earth's radius, it's the largest ratio between a satellite and its planet. Its gravity is about 1/6 of Earth's. If you thought that would help you jump super high, consider that you'd have to be wearing a bulky spacesuit. See, the moon has almost no atmosphere to speak of. It also has barely any magnetism or volcanism. What it does have is a lot of mass, which influences the Earth. Not only with tides, where bodies of water swell twice a day. The moon literally makes our days a bit longer. We always see the same face of the moon. We say it is tidally locked to our planet. Here's what the far side looks like. Some call it the dark side, but that's obviously wrong. Depending on its alignment with the sun, a different part will be illuminated. This is what causes the phases, and a cycle lasts about 29.5 days. This regularity led people to use it as a sort of monthly calendar in the past. It was pretty mystical for them, especially with the eclipses and all that. Even though the sun is like 400 times wider than the moon, it's so far away that it can be hidden behind it. The distances vary a little because orbits aren't perfect circles. That means a solar eclipse can be annular, which means you can still see a ring of sun. Now, how has the moon come to be? The most widely accepted theory is pretty wild. Over 4.5 billion years ago, the Earth was smaller and still pretty young. Then a Mars-sized object called Theia crashed into it. The impact combined both, but went on and ejected some mass up to the right distance for it to orbit the Earth. With time, gravity made both bodies become spherical again. The dark spots are actually volcanic rock from way back. The lighter stuff is dusty rock. That stuff is technically not much more reflective than old asphalt, but optical effects make it seem pretty bright. And the craters you see are the result of common impacts. Without an atmosphere, the moon can't disintegrate meteors as easily as the Earth. Also, without wind, rain, and so on, the craters can stay there for billions of years. Despite the temperature ranging from 140 to -170 degrees Celsius, we might one day settle there. There's a lot of valuable minerals there after all. And with that, I'm off!